Hi, today we're going to do number 121, best time to buy and sell stocks. So we have an input, which is an array of numbers to symbolize the price. And we want to return the maximum profit. We get the maximum profit by figuring out which day we want to buy the stock and which one we want to sell. Buy low, sell high. So for this one, if we buy it at the value 1 and then sell it at value 6, we get a maximum profit of 5. And none of the other ones can compete with that, because if we buy 7, sell 1, we have a negative value. Buy 1, sell 5, we have 4 profit, for example. And in the case that there's no transaction that's done, so we don't want to make a loss, the output is just 0. So how can we do this? The first way is the brute force way, where we check every possible combination with the nested for loop. And not necessarily in every, we check this one, this first value, compare it with this, and then here, compare it with what's after, we don't have to go backwards. And we calculate the profit for each compared values and then return the maximum. So for this, if the time complexity will be O of n squared, since we're doing a nested loop, comparing the first value to the rest of it, and we keep doing that for the length of n, where n is the price. The space complexity will be O of 1, since we're just using that constant space. Now, how can we make this better? Another way we can do this is to use pointers. And we can use left pointer for when we buy, keep track of lowest one. And then we use right pointer of when we sell. And then we do a while loop for this, while right pointer is less than the of prices. So we'll start here and here. So we'll buy 7, sell at 1. Since this isn't going to give us a profit, we have to go increase both. So it will be 5 and then 1. We'll move the left pointer and the right pointer by 1. And then in this one, we compare it. If it does give us a profit, we keep track of it, and this doesn't change. But then this changed because it's a profit giving value, and we know this is the lowest that we've seen. And so this one will give 1 and 3 will give us a profit, 6 and 1 will give us a profit, and 4 and 1 will give us a profit. Compare each one. If it's the max profit, we update the max Profit. If the difference is profit, we check the running profit and then increment right, and then we just always so if there's and then so if this is a profit, we just increment right. If it's not a profit, the right becomes the left. Where the left becomes the right. Then increment right as well. So how can we make this even better because here we're using 2 pointers. What we know that it's just we can be greedy with this. We know that we have to keep running total of lowest by and keep running max profit, and then we iterate through this and can then compare it. If it doesn't beat the lowest by or the max profit, we don't update it, and then we just return the max profit, since we only care about the lowest that we have seen. Oh, I forgot the time complexity. So for this time complexity, it's going to be O of n since we're looping through it. And we'll do a space of O of 1 since we have constant pointers. So this also is going to be O of n time and then O of 1 space since we're looping through it once, and then keeping constant variables of the lowest by max profit. So this, since the greedy is simpler with a simpler iteration with just one loop rather than 2 pointers, we will go with the greedy solution, but then I will show you how to do it with other ways afterwards. So here we do let max p, I was going to say max profit, but the function is already max profit, and we have it set it equal to 0, and then we get the lowest by, and we can initialize it with prices with the first one. Now we loop through it, and since we already have the lowest by of 0, we can just start with the first index. Now we just update these spreading values. So path.max, the current max, or minus and then we have to do the same for the lowest by, but the opposite, which is the lowest. And then we just return max p. Sorry, this should be the lowest by. Great, so now we can do it with the pointers. So we're going to keep the max p, and then we have a left pointer and a right pointer. And that can be the next value. So while right is less than prices.length, now we calculate the profit. Now we do a while right is less than prices dot length. So we only want to update the value if this right value is greater than the buy value, which is the left. So if we want to do max p equals math.max, and then the profit. And then else, we just update the left to be the right. If it's not like this one. So if there's a negative value, we just update this new buy to be here. And then we will increment right either way. Great, and now we can do the brute force way. So we're going to still keep the max p, but then we're doing nested loops. And then here we can do the current profit. So a time limit because it's inefficient. But those are three ways we can solve it. We can either do a brute force, where we compare all values and calculate the profit for each one, and have a running total of the max profit. We can do pointers, where we have a left pointer of when to buy and right pointer of when to sell, and we iterate it. Or since we know that we only care about the lowest buy and the maximum price, we just have a running total of it and replace it with it as you go through a loop. And that's all. Thank you.